Hi everyone, Teacher Yong here from Yong Academy. So today we have a few questions from past years uh, that our students have asked us. So today we'll be going through them and hopefully everyone can learn something. Also, by the way, the questions today are all IGCSE based questions. So it's from past years. So yes, let's jump straight in. Okay, so these are the questions that this student, the mistakes that this student has made in their IGCSE exam. So let's look through one by one, and then I'll go through why and how to do it better the next time. Okay, so let's look at question one. So of course, we start by reading the question. A scientist heats a sample of solid. All right. So normally I like to pause after each sentence, just digest what it means. Even though this sentence is very simple. All right. So the scientist heats a sample of solid, right? Okay. The scientist measures the temperature of the sample, plots a graph of the temperature. So if we look at this graph here, where's my pen? All right. So if we look at this graph here, clearly it is the heating slash cooling curve that we have learned, okay? In case anyone is not sure, let me just pull up example here, all right? Heating curve, okay? So in case anyone doesn't remember, let me just show you all. Very simple heating curve. Everyone should have studied this thing here, you know? Fill for water, we know that the first point is at 0 degrees because that's the melting point where it converts from solid to liquid, and then at 100 where it converts from liquid to gas. So this is where we learn this thing for the first time. So we did learn this in our syllabus, all right? Okay, so that's a heating curve. You can screenshot this if you want. All right, I'm going to remove it now. So coming back here, we can see that it kind of works the same. It's just that it's not so sharp. Like just now, the edges was more pointy, but it doesn't really matter because the graph is showing the same thing, all right? So now let's read the question. Which statements are correct? Between point W and X, the temperature increases and moves, and the particle move faster. So okay, maybe where was it? Okay. Maybe what we can do is we put it back here. Okay, so let's just do a recap on this. So looking at this, here is where the temperature increase because you see here, this is the y-axis. Y-axis is temperature. So when the value goes up, means the temperature is increasing. However, here the value stays the same. That means the temperature stays the same. So what is actually happening here? The heat energy absorbed is used to break the bonds, or what we can call overcome the bonds between the solid. They are breaking the solid. So solid is drawn like that, correct? Not lattice structure, in case everyone remembers. We are breaking the bonds and turning into groups of particles. Because if you all have memorized before, liquid is kind of like solid, but they are not perfectly arranged. They are in like one group here, one group here. So the heat energy is used to break the bonds. So therefore, there is no change in temperature. Whereas in this part here, where it was going up, it is heating up the solid, causing it to vibrate faster and faster. So in case any student haven't learned this before, temperature is how fast the particle move, whether vibrating or moving. Moving for liquid and gas, vibrating for solid. All right. Okay. So that's just very quick recap on the solid liquid gas chapter. All right. I hope you all caught it. Okay, so that is the one. So here they say between point W and X, which is the going up phase here, the temperature increase and the particles move faster. So that's correct. So what we can do is we put a tick behind here. Second one, between point X and Y, That means here, which is the flat line. What did we talk about it just now? The temperature is not increasing because the particles are not moving faster or vibrating faster. What happens? The heat energy is used to break the bonds. So let's see what this one here says. There is no change in temperature because energy is needed to change a liquid into a gas. Okay, so the problem is a liquid into a gas because it might be a solid to a liquid. You know what I'm saying? It's not 100% liquid to gas. So you see here, the question already say very clearly, is heating a solid. So that means starting this W here, it should be a solid. So if here is a solid, here should be a liquid. So I write a S here, a L here. So it should be solid to liquid. So this, what does this teach us? This teaches us that we must read the question, okay? Don't always just jump down here and read this part. You must read on top here. So this is a very good example because if students didn't know that this is a solid, they cannot choose whether this is right or wrong. Okay, the only problem is this liquid to gas. It should be solid to liquid. Okay, I also teach my students, you must always not only know that it's wrong, you must know how to change it to the correct form. That is what an A-star student should know how to do. All right. Okay, last one, number 3. Y to Z, the particles move further apart. So when we say move further apart, this one, we can only say for liquid and gas. Because only liquid and gas, they can actually move. For solid, is vibrate. So if I was the examiner, if I change this word to vibrate, maybe it might cause some students to confuse also. But because here, Y to Z is here, it is a liquid. So liquid, yes, it can move. So it's correct. So this one is correct. So the answer is 1 and 3. Okay? All right. Any more questions? Y'all can ask it down in the comments. But because this is a past year question, so I won't really go too deep into teaching the chapter. All right. If y'all want me to recap some of the chapters, just comment down below. Maybe I'll recap it when I have time. All right. Okay. Next question here. So there's 3 isotopes. Isotopes means same number of proton, but different number of neutron. Okay, so all students going for exam must memorize this. Let me type it out for you. Okay, same proton number. I'm just going to type short form here. Different neutron number. All right. Make sure you all have this saved inside your brain. Okay. It's like, okay, got it. Okay, like, yeah, okay, let me put it nicely this side here, okay? That's the definition of isotope. They love to ask this in exam, okay? All right, so there's 3 types of isotopes. So that's how it works in nature. A lot of elements, they will have isotopes. Not all, but quite a few have isotopes in nature. And then it exists in percentage, all right? Exists in percentage. So this one is a very basic mathematics problem, okay? So relative abundance, when they say 1, that means it's like, okay, so let's calculate first. This relative abundance, the total is how much? So this one is 1, so I just write a 1 here. Here I write a 5. Here I write a 2. So 5 plus 2 plus 1 means that the total abundance is how much? Obviously 8, correct or not? Okay. So what we can do is, so they want the relative atomic mass. So normally when you see this relative atomic mass, you can understand it as the average mass. So the average mass, what we can do is we just, let me change a different color. 1 over 8, right? Because 8 is the total. Like what we learn in mathematics, what you want to find divided by the total times the value. So here is 20. So 1 over 8 times 20 plus 5 over 8 times 22 plus 2 over 8 times 24. All right. So you calculated this whole thing. Okay, I'm going to use my own calculator here. Y'all can do it on your calculator as well. All right. So this is 2.5 plus, what's this? 13.75. Okay, pardon my ugly handwriting, okay? And then 24 times this plus 6. Okay? But for the more pro students, oops. For the more pro students, what you can do is you just type it all and just get the answer straight away. Okay. All right. Let me just calculate that. Okay, so the answer is actually 22.25. Okay, so here we can see that all the answer here, they round it up to 1 decimal point. So we must be very specific. So if we round it up to 1 decimal point, it's 22.3, correct or not? Because this 25 rounds up to 3. All right, so therefore the answer is B. So student must be very exact with their calculation. Please do not round up your answer, all right? That's all. I don't know what else to teach. Okay. One other thing that I can maybe tell you all is sometimes when they ask this relative abundance, it might, so this one we can say is in terms of fraction. So like you have to find the total like 8 and then 1/8 it. Sometimes they ask it in terms of percentage. So I hope you know percentage from learning maths in school. So if you are clear on the percentage formula, then you should have no problem. You just like let's say 20% over 100% times that mass, and then 50% over 100% times the other mass. I hope you are clear on that. If you still have questions, ask it in the comments below, or you all can feel free to WhatsApp me as well. All right, let's move on to the next question. Okay, so here we have three solids, so X, Y, and Z. Okay, so when they say three solid means all of this here is a solid. Okay, solid, there are two types, all right? There is actually three types if you go deeper. What are the three types? Metal, all right? Non-metal. And the third type is a salt. A salt means we have plus and minus. Why? Because I saw this one here, plus and minus. So this one clearly is a plus and minus. So we can say it's a salt. One name is called a salt. The other way to call this is a ion. You know what? I actually don't have space. So maybe let's type it out. Salt, or what we call ionic compound. Okay. In case you haven't learned this in class yet, then yes, please go back and do some revision, or yeah, comment down below. Maybe I'll teach this in a lesson next time. Okay, so this is a salt slash ionic compound. Basically, salt slash ionic compound is a plus and minus combined together. All right, but of course it can be deeper than that. All right, but today we are doing past here. Okay, today we are not learning that chapter. This one here. Okay, so the special thing about metal, so ionic compound or salt, the special thing is there's plus and minus. This one here, when you can see a lot of electron like can flow around, we confirm no it's metal, because that's why metal can conduct electricity, because metal can conduct electricity because the electrons can flow freely inside of it. Okay? It's deeper, but maybe we'll cover it in another chapter. That's the general explanation for today. And this Z here, there's nothing special about this Z. So maybe it's just a non-metal, okay? Or something, if we had to guess. Or we can say a normal solid, okay? Yeah, nothing special about this. But we know for sure that this is not a metal. Okay, so I think I have kind of given out the answers. So then we only need to know what here for X is a salt. Like what I just said, salt is a plus and a minus. So if y'all have studied periodic table before, you would know that sodium is Na plus, chloride is Cl minus. So you see here, there's a plus, there's a minus combined together. So that means sodium chloride is correct. This one is not correct. I mean, even if you all don't know that who is plus, who is minus, you should know that plus is 1%, positive is 1%, negative is 1%, correct? So when you see krypton here, it's only krypton. There is no minus. It's just a plus. Of course, that's wrong, okay? Even if you had to guess, you should guess it. And then here, krypton and potassium. But we know that this is metal. So you open your periodic table, you find, all right, krypton is obviously not a metal. Potassium is because it's in group 1. Okay, so everyone, please go check your periodic table. I'm not going to pull it up here because periodic table is too big. But I hope everyone is clear on that. And then this one here, we learned that we observe that it's a non-metal or what we call a normal solid. So that means it should not be a metal. So this one you see here, potassium, they put here also wrong because potassium is a metal. Krypton is a non-metal, so it's just right. That's all I can say for this question. I'm going to move on. Number 7, an element with a high melting point forms an oxide. Okay, so, all right, that is gaseous at room temperature. Which type of structure or bonding is present in the element? Okay, let's just reread that. Everyone reread that in your head, okay? Okay, so there's two special things about this. One, this thing is a high melting point thing. Okay, so before thinking too much, let's just read the answer here. Which one has a high melting point? Based on what we learned, let's look at giant covalent. Yes, confirmed giant covalent has a high melting point because if you all learn in your syllabus, it should be the diamond or graphite structure. Both is known to have high melting point. So yes. Then for ionic, yes, most of the time ionic has a high melting point because it's a plus and minus, which we just learned in the previous question. Ionic compound is plus and minus. The attraction force between plus and minus is very strong. So yeah, they normally have a high melting point. Metallic also, they have high melting point. Simple molecular is out. Simple molecular is like the name itself already says simple. So it's very easy to break their bonds and turn it into a liquid form. So no, it does not have high melting point. Then the next thing that we can look at is and forms an oxide that is gaseous at room temperature. Okay, so we look at giant covalent first. So giant covalent is made up of carbons. All right, so carbon could form an oxide, okay, and is a gas at room temperature. Carbon monoxide, carbon dioxide, most likely, right? But you have to learn this giant covalent. If you all learn it, you all would know that it's mainly made out of carbon. Next, ionic. Ionic can be made up of anything as long as it's a positive and a negative. So the possibility is endless. There's like all kinds of things you can make with ionic. And out of all the different things that we can make up with ionic, there's so many things. Some are oxide that is gas at room temperature, but there's a lot that is not a gas also. So this one I'm going to put a tick. This red color one, I'm going to put a tick. This one we cannot really say because we can only say it if all the ionic forms an oxide that is gaseous. But sadly, only some of them form an oxide that is gaseous, some do not. Okay, or if you all want to know even clearer, don't need to think that deep. You just think back in your syllabus. Have you studied ionic that can form an oxide that is a gas at room temperature? No. Most of the time, ionic, when they form an oxide, is a solid at room temperature. Give you an example. Copper oxide, aluminium oxide. All this, of course, the formula here, this one is Al2O3. They are solid at room temperature. They are not gas. So like that is another way you can tell. Okay. Next, metallic. Again, like the same example that I give here, metal can form an oxide, but they are not gas at room temperature. They are a solid at room temperature. So this is also out. Okay, so you can also use the guessing method to guess this answer here. But yeah, it is a little bit more difficult. All right. Okay, next question. Number 8. Which substance has a giant covalent structure at room temperature? So we just say giant covalent structure is either, what's that called? Graphite. I mean, the two examples that we learned in our syllabus is graphite or diamond. Okay, so let's see here. Is there graphite or diamond? Okay, don't have. If don't have, like, oh, I never learned this before. Okay, don't worry, don't panic. One thing we can do is we do the elimination method. Let me type it out. Elimination method. So what we can do with this method is, you look at this question here. So like methane, we already learned methane in the hydrocarbon chapter, right? So methane confirm is not what we call a giant covalent, because methane, if you learn, is CH4. Giant covalent is like when you have 100 and 100 or 1,000 or million of this carbon connected together. Or it can be other things, but it has to be a lot. This one is just CH4. It's just 5 things connected. So confirm is not giant covalent. Yes, it is covalent, but it's not a giant covalent. Okay, this method, so it's out. Sand, we are not sure. Sodium chloride, confirm no, because sodium is plus, positive. Chloride is negative, so it's an ionic compound. It's not even covalent, so out. Water is H2O. But like I said, H2O, yes, it's also covalent bond, but it's only 3 things. So it's what we call a simple covalent. So you cross out all this, who is left? Sand. So we just choose sand. Okay, so we just choose sand as a giant covalent structure. Okay, that's very simple. But if you want to be an A+ student, you can write it into your book. Giant covalent is, one other example is sand. Okay, all right, let's move on. Let's change color, all right? When one volume of gas R reacts with exactly 5 volumes of oxygen. Okay, it forms carbon dioxide and water. So let's write it out. R plus O2. We cannot exactly relate it because this volume. This one here is mole. Actually, we can, because, okay, this one is going quite deep. I hope you all have learned this, but one volume of gas at STP is 22.4, and then at RTP is 24 dm cubed. So because it's a direct conversion, like 1 mole is 24, so 2 mole is 48. Don't even care who are they. As long as they are 1 mole, their dm cube, their volume is 24. So I think we can say that 1R plus 5 mole of this oxygen will give us CO2. I mean, we can't balance the equation yet, but we can write this out. And water only. And this H2O. Okay, so this R here, so like when we learn balancing equation, right? We learn that how much carbon go in, how much carbon must come out. How much hydrogen go in, how much hydrogen must come out. Oxygen as well. So we can see that oxygen is going in here, is coming out here. But what is coming out here that is not going in? I hope you all get what I'm saying. Carbon and hydrogen, correct or not? Where did my carbon and hydrogen come from? So clearly, these are, no matter what it is, it must have carbon and hydrogen. Yes or no? All right. Okay, so carbon and hydrogen. Oh, but is even more complicated than that. Wow, this one is actually a bit, I wouldn't say difficult, but I would say wasting time. So this R here, we must replace it with one of this. So the only way we can do it is trial and error. So I'm just going to do the wrong question that the student chose, C2H6. So in exam also, what the student should do, like if you all see this question, the only way is you trial and error. So your balancing equation must be very fast. One thing we cannot change is because they say 1 and 5. So this 1, we cannot change. This 5, we cannot change. It must stay that way, okay? So let's say we try to balance this C2H6, right? Oh, okay. So in that case, the oxygen is fixed. We can only have 10, because 5 times 2, 10 oxygen. So here got 2, here got 1. So the easiest way, the only 2 ways we can balance it, I might be wrong, okay? I'm also human. But the only way we can balance maybe is here 3, then we get 6 here, and then here we do 4, right? Yeah, we either can, the only way to get combination of 10, because this oxygen here must times 2. So it's like 2x plus y must equals 10. So the combination of x and y can only be x equals 3, y equals 4, or 4 and 2. Is there any other combination? I don't think so. Or the last one maybe is like 1 and 8, because 1 times 2 is 2 plus 8. Then you get 10. Okay, maybe let's not make it so difficult. Let's just try to do it like that. Okay, so if we put C2H6 here, right? How will we balance it? Let's say I use a different color. Okay, so first, going in, and then here this is confirmed must be 1, because they say it's 1 volume. So going in 1, so this carbon here is 2. So that means coming out, your carbon must be 2. Okay, so let's say we write 2 here, because we want to balance the carbon, right? And then this hydrogen is 6. So 6, then here we must put 3. 3 times 2 here, then only we get 6. Okay, so then now let's balance the oxygen. So oxygen 2 times this one 2 here, so we get 4 oxygen. Let's use a different color. So here we get 4 oxygen. Here 3 times this is 3. So the oxygen is not balanced. It's 7. Whereas here is 5 times 2 is 10. So therefore this one is out. I hope you all are clear on that. It is rather complicated. Okay? So the best thing y'all can do is y'all please ask your teacher for an extra paper so they can do all the possibility on that paper. Okay, next possibility. I'm just going to jump straight to this one. Y'all can try out with all the other answers. But here I'm going to write C3H8. All right. Okay, so coming out here, you have 3 carbon, because going in carbon is 3, coming out carbon is 3. Then going in hydrogen is 8. Coming out this one here, you should put a 4 here. So because 4 times 2, you get 8. Then now let's balance the oxygen. So 3 times this 2 is 6. 4 times this one is 4. So 6 plus 4 is 10, which is same like this one. Just right. That's why donkey is the answer. You can go try out this one and this one. You will not get the perfect balance. That's why those are wrong question, okay? All right, next question. A mass of 63 grams of potassium manganate, KMnO4, is needed to oxidize 23 grams of ethanol. Huh. How many moles of ethanol? Okay, so maybe the first thing we do is we find this one. So KMnO4 plus C2H5OH. So if y'all have learned the what's that called? Oh, sorry. No. This one is just oxidation. My apologies. Basically, these two is reacting with each other. So it's like A reacting with B. No need to think too much. I know that the words here is like very complicated. It's like, wow, I never seen this before. I don't know how to do. But you just think of this one as A. Think of this one as B. So they tell us this one here is 63 gram. So do y'all know how to convert mass to mole? Mass divide by molar mass. So you go find this periodic table. Oh, okay. So I guess for that, we have to find the periodic table. All right. I'm going to open it on my side. Okay. And maybe I'll just share it very quickly with you all. All right. But y'all need, especially exam students for periodic, for chemistry, y'all need to know need to have the periodic table, all right? So let me just share the screen here. Okay, so I'm just gonna show an example of the periodic table, all right? But okay, after this, I'm gonna come back here. Y'all please go find it by yourself. Okay, I just do one example. For example, like potassium. So potassium, the mass, you remember potassium, we take the bigger number, which is this 39. This one here is the proton number. All right, if y'all need a recap on this chapter, again, comment down below. Okay, today I will not be recapping this chapter. I'll just tell you straight that this is the mass 39 here. Okay, so the rest, y'all, please find it by yourself. Okay, like manganese, Mn. So Mn is this one here. So the mass is 54.9. So we round it up 55. Okay, oxygen is here 16. Okay, so the rest, y'all, please find it out by yourself. Let's come back to the question. All right. Okay, so coming back to this question. All right, so just now we were finding potassium is 30. Wow, we actually need a lot more space for this. Okay. So let me write it smaller. Okay. Potassium is, how much was that? 39. So this one here, 39. And then manganese is 55. Okay, y'all please double check on your end, yeah? And then this oxygen is 16. But remember, must times 4 because there's a 4 here, all right? Carbon, y'all should memorize this by now, is 12, all right? But there's 2 of it, so we times 2. H is 1, and then 5 times 1 is 5, so I'm just straight away going to write 5. Oxygen is 16. Hydrogen is another 1 here, okay? So let's calculator it, and then maybe, okay, I'm sorry if it's a bit messy, but I'm just going to squeeze it here and here, okay? So the total here, let me just get a calculator. Here, okay, 39 plus 55 plus 16 times 4. So this one here is 158. All right. This one here, let's write that bigger, okay? Is okay, 2 times 12 plus 5 plus 16 plus 1. So this one here is 46. All right, so mass divided by molar mass. So 63 divided by 158. So this one here is 0.3. If we round up, I think it's 0.4, all right? And then this one here, this one 23 divided by 46 is 0.5, just to double check, even though I kind of got it, all right? 0.5 here, okay? 0.5. All right, so the mole is 0.4 reacting with, wait, did I calculate that correctly? 39 plus 55 plus 60 times 4. Then, let me double check this KMNO4, all right? One moment, let me just double check. K is 39. Yeah, nothing wrong. Mn is 55. It's correct. Oxygen is definitely 16 times 4. Okay. So, yeah, should be correct. It's just a very weird number. All right, then they say, how many moles of ethanol, this one here, can be completely oxidized by 1 mole of potassium manganate. So this KMnO4. So the easiest way is you memorize 0.4 ratio with 0.5. So now we are learning a little bit of maths. Yeah, your teacher should have told you, chemistry also you need some maths. So this 0.4, change it to 1. So if you change this 0.4 to 1, the easiest way is you times 2.5. Then you get it to become 1.0. Okay, don't believe me? Type it into a calculator. 0.4 times 2.5, you get 1. So therefore, you have to be fair. If here you times 2.5, here also times 2.5. So 2.5 times 0.5, 1.25. Okay, so I wouldn't say it's difficult, but it's not that easy also. All right, so I hope you get it. If you still have questions, please ask. You say like, I need more clarification on question 10, and I'll answer you. All right. Okay. The diagram shows an electrolysis. All right. So now you look at the next question. Okay. So what could liquid Y be? So you see here at anode. So at first it's full of water. But after coming out here, there's gas. Here, there's gas. Okay. So what could liquid Y be? Okay, this one. Okay, let's do this copper 2 sulfate. I just do two. I'll just do your wrong answer and the correct answer. So if we do copper 2 sulfate, CuSO4, okay? Anode and cathode, okay? I'm writing short form here, plus and minus. So who will appear at the anode? So you have SO4 2 minus, pardon my ugly handwriting, and OH minus. Why? Because it is aqueous. So you have OH minus. And then here you have Cu2 plus, and what is that? H plus, because it is water. All right. If you all want to know more about this, please comment down below that you need help with electrolysis chapter, and then I will maybe teach it one day. All right. Okay. Okay, so if you look at the electrochemical series, okay, so let me just pull one from Google, all right? Electrochemical series. Okay, because in electrolysis, we need to look at this, all right? Which one is a easier one? I guess this one is good. Of course, we use a slightly different one in our class, but for today, I'll just use this one here, okay? So you can see here, or wait, maybe I can put it this side here. Yes. Okay, so you can see from here, all right, in electrolysis, we choose the lower one. So OH minus is lower than SO4 because you see SO4 is high, OH minus is the lowest one. So we choose OH. And then Cu and H plus, Cu is actually lower. So do you like OH minus, you produce a gas. Cu minus, will you produce a gas? No gas. Correct, there is gas. But in this question here, excuse me, they show that anode and cathode both must produce gas. So when you see that here there is no gas, then it's wrong already. All right. Then now let's say we do the correct answer here. Okay. Dilute sulfuric acid, H2SO4. That's very ugly. Let's rewrite it. Okay, again, we have the anode and the cathode. So here you will have SO4 2 minus and OH minus. Of course, OH minus will get chosen because same here. SO4 and OH is the lower one. Then here you only have H plus because here you get H plus. Water there also you get H plus. So H plus. So yes, there is gas. Yes, there is gas. That's why C is the answer. And also let me explain a little bit deeper. In this cathode here, your H plus is double portion. You get H plus from here, the acid. You also get it from the H2O itself. So like you're getting double portion. That's why in the negative here, you can see the gas is double of this gas here. That's the deeper explanation, which I don't think you really need to know to get the answer. Okay, I hope you're clear on that. Next question here. Calcium carbonate is used to produce carbon dioxide. So, all right, the reaction is done 4 times. For each reaction, 25 grams of calcium carbonate. Okay, let me just read it one more time, yeah. Okay, here, calcium carbonate reacts with dilute hydrochloric acid to produce carbon dioxide. Okay, so here they are reacting, and then when they produce this carbon dioxide, it comes up here, and then they are measuring the cm cube of carbon dioxide produced. Okay, so I hope everyone is clear. The reaction is done 4 times. For each reaction, 25 gram calcium carbonate with excess of hydrochloric acid. Which reaction mixture fills it? Okay, so this one comes from the rate of reaction chapter. Like what increases the rate of reaction? So we look at on top the first word here first. The first thing I normally do is I look at the answer. What are the difference? Lumps and powdered. Powdered means the surface area is larger because it's powder. Lumps means it's one big piece. Okay, if you didn't know, you write it down into your notebook. Powder means the surface area is higher, and we learn in the rate of reaction chapter, the higher the surface area, the faster the reaction, because here they want the shortest time. That means they want the fastest reaction. So that means this powdered and this powdered is correct. This one is out, this one is out. All right, the next thing that we want to look at is 1 mole dm cube or 2 mole dm cube, the concentration. Of course, the concentration must be higher. Okay, let me show you all the difference between high and low concentration. All right, let me show you a photo so that you can see clearly. Okay, so coming over here, you see low and high concentration. So y'all can see this low and high concentration, right? Which one will react faster when you have more of it or less of it? Of course, when you have more, because the exam answer also is when you have more, they will knock each other more frequently. That means more times they will knock each other. When they knock each other's more times, they will react faster. Okay, so donkey. That's it, nothing much else. Yes, 3 more questions. Ooh, okay. 3 separate mixtures of a solution and a solid are made. Okay, so we have solution, which, why do they not use liquid here? Because solution means there's something dissolved in the liquid. So it's not pure liquid. So you all must know the difference between solution and liquid. Solution means a solid mixed inside a liquid, most likely. Or maybe it's 2 different liquid mixed together. That's what we call solution. All right. Also, you all should know solute and solvent make a solution. And then we have a solid here. All right. So the mixture are warm. In which mixture does a gas form? Okay, so this one here is alkali because it has a OH. If you all learn in acid alkali chapter, you should know that all alkali have a OH in their formula. All acid have a H plus in their formula. Okay, so this one is an alkali. Alkali react with NH4Cl. So NH4Cl is actually a salt because if you all learn properly, NH4 is positive, Cl minus is negative. You all should look at the polyatomic ion table. Okay, we have one in our class. All right, so for my own students, all right, that's where you need to look. And for outside students, maybe you can find it online. You should be able to find it. All right. Okay, NaOH and NH4Cl. So this is the reaction between an alkali and a salt. Okay, so for my own students, we have learned all the different reactions. Actually, for all students, you should have learned the reaction of alkali with different things. There should be 3 or 4 equations that you should have memorized and like copy into your important notes. So will this produce a gas? But actually, even if you don't copy that, let's guess what will happen. This Na plus will replace this because clearly Na plus is more reactive. So when Na plus react with this, it will kick out this NH4. NH4 when kicked out, it will become NH3. NH3 is ammonia gas. Okay, and on top of that, you have OH. OH, most high chance, it will form maybe some oxygen and some hydrogen gas. Or maybe it will form water. But even if OH form water, you have this NH4, which will form ammonia gas, NH3. Okay? So this one definitely is correct. Right? So this is correct, this is correct. This one, acid and a salt, or what we call an ionic compound. Again, this H will get replaced. And this H, when it gets replaced, it will form, wait, one moment. One moment. Let's so this one you all need is more memorizing, all right? So H2SO4 plus NH4Cl, okay? You react it, we will get, okay, this one, I think most likely what will happen is this H will react over here because you all need to look at the reactivity series. That means who is more reactive? In this case, H and Cl is more reactive, all right? In our class also, we have this, all right? Just refer to the electrochemical slash reactivity series, all right? HCl plus NH4 bracket 2SO4. Okay, so this one is a bit more special. They will not produce a gas because they will actually replace each other. We call this a displacement reaction. So this one is correct. This one is correct. By this time, we should find our answer already, but let's say we try the last one here. So H2SO4 plus Mg. Okay, so what happens is Mg definitely is more reactive than H. So Mg will replace it, SO4, and then your hydrogen, when left by itself, it will be a H2 gas. Excuse me. So, of course, this one will have a gas, so this one is correct. So therefore, the answer is B. Okay, next question. Some atmospheric pollutants are listed. This one you have to read the chapter where the different pollutant of gas. Okay? Okay, so which substance could be removed by reacting with calcium carbonate? This one, the only way you can do is you have to memorize. Yeah, that's all I can say. Okay? Especially sulfur dioxide. Very, very important. Sulfur dioxide. But okay, if you all want one simple explanation is calcium carbonate can be used to remove things that cause acid rain. And if you learn, these two causes acid rain. Or just remember, calcium carbonate can be used to settle these two. We actually learned this in our class as well, but it's a little bit deep to go into today. Yes, and or you can do the elimination method. Methane definitely cannot react with calcium carbonate because methane is in the hydrocarbon chapter. There's only one or two reaction it can do, and definitely it is not with calcium carbonate. Number two, unburned hydrocarbons. Again, we have never learned in any place hydrocarbon can react with calcium carbonate. Elimination method also can help us find the answer. And for the last question of today, oh, happy. Okay, which statement describes the CH bond in methane gas? So it is a sharing of electrons, all right, in case y'all didn't know. How our chemistry syllabus works for IGCSE, in front we learn all about ionic bonds, plus and minus, or okay, maybe you should say positive and negative. Acid and alkali also is ionic bond because it's a positive and a negative. But in the hydrocarbon bond, it is covalent bond because they are actually sharing electrons. All right. But okay, doesn't matter because it looks like that's not what they're asking in this question. But it's good that you all know. Okay. How does CH bonds in methane gas in the atmosphere contribute to global warming? Okay, so again, for this type of question, don't think so much because I know students in the exam, your brain is try to keep your brain as chill as possible. Don't need to stress your brain out. So you just read the answer here. So everything is same, right? The only difference here is sun and earth. So which one do they absorb? Okay, so in case y'all didn't know, so this is our atmosphere. Okay, you know what? Maybe I use green to draw our earth, all right? So this is our earth. And then our atmosphere is like an outside layer here. So when you have a lot of this CH4 gas blocking here, what is the logic here? When the sunlight comes in, it doesn't block. But when your sunlight wants to go out, the UV ray, right? And we learned that UV ray carries heat energy. So when this heat energy in the UV ray wants to go out, it cannot. Why? Because this methane is so thick that it blocks it and it reflects it back to Earth. So normally it's supposed to go out here. But what happens is this CH4 reflect it back to Earth. So what happens to Earth? Of course, it will become hotter and hotter because it reflects it back. Something like how, you know, when we heat up water, we put a cover on top so that the steam that comes out, we force it back in so that the heat energy, maybe some students don't get it, so it's okay. So I hope you all get this example, all right? So it's from the Earth, okay? They are shooting back the heat energy from Earth, all right? And emitting some of this energy towards Earth. Oh, yes. Okay, so this student say all of this energy. Why? Because if okay, so this question actually asked quite deep into the what? There is still a small percentage of the UV ray that can go out. So in reality, maybe it's more of like a 60% or maybe a 50%, okay, of the UV ray can actually escape. But the problem is the other 50% that was supposed to escape together gets shoot back at Earth. This come down here is another 50%. So that's actually the deeper explanation how it works. So there is a small percentage that can actually go out. It's not 100%. If it's 100%, then our Earth would be in a much worse condition, okay? We wouldn't be as nice as right now already. It would be much worse. Okay, so the keyword here is some, not all. And with that, we have finished all our questions. So I hope this has helped you today. If it has helped you, please do give a like and a share. Share this with your friends, right? Yeah, introduce your friends to watch the videos. And yeah, any questions? Ask it down below. Would be happy to help once I have the time. All right. Let me know what other questions you'll have. And I'm gonna end it here today. See y'all in the next video. Thank you.